In this section, we're in section 9.2, if you want to look at the drawings in your book, we are going to be looking at ellipses. And I've drawn an ellipse here, and at this point I want to label a few things for you. The ellipse is going down the center. So this is the center of my ellipse. It's exactly in the middle. And then it has two foci. If we talk about a single line, it's called a focus or a foci if we talk about both of them. And these are these 2 points. When we talk about the locus of points, the set of points that make up an ellipse, we're talking about the sum of the distances from the 2 foci. So if I were to connect this foci to any point on the ellipse and then connect that same point to this focus, that sum would be exactly the same as if I came all the way over here and connected to this focus. If I took those 2 distances, they would be the same if I added them together. All right, so that's what an ellipse is. An ellipse has 2 axes. It has a major axis, which just means the longer one. In this case, the longer axis is horizontal, so we call it the major axis. And the major axis has a length of 2a. We're going to use a here in just a minute. So the distance from the center to one of these ends out here, one of these vertices, is going to be the distance a. And then we call this distance from here to here the minor axis because it is the shorter one. So the minor axis is here and it has a length of 2b. b is always smaller than a. And we have an equation that we can use to relate our foci to those at A and B. C is considered to be the units from the center. And that C can be found with C squared is equal to A squared minus B squared. So whatever this distance is from the center to the focus is C, and it can be found by saying C squared is equal to A squared minus B squared. I'm going to use that here in a few minutes. The equations for ellipses depend upon whether our ellipse is horizontal, like the one that I have drawn here, or vertical, which means it would be tall. If it's horizontal, the equation is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now, obviously, h and k are going to be my center, and we talked about what a and b were. A is half of this major axis, the distance from the center to the edge, and b is this radius along the minor axis from the center to the edge. If it's vertical, then b is going to be underneath my x because it means that it's going to be a tall, skinny ellipse instead of a short, fat one. So x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And 1 is important. We're going to run into that a lot in some of our problems. But right now, let's just look at one simple problem and see what we can find out. X plus 5 squared over 16 plus y minus 2 squared over 25 is equal to 1. So I've got a question. What's the center of this ellipse? Well, that's pretty easy to find. We simply have to look at our equation. Our center is at negative 5 and 2. So we got that. That's simply h and k. Now, what are the equations for the foci? Well, the foci are going to be found by figuring out what c is. Remember, c squared is equal to a squared minus b squared. So a squared here is this 25, and the b squared is equal to 16. So, 25 minus 16 is equal to 9. Well, that means C is equal to 3. Well, okay, so which direction is this opening? Is this a vertical or a horizontal? Which one's bigger? This one was bigger. So considering the fact A is got to be bigger, this is a vertical. So I have 25 minus 16 is 9, take square root, I get 3. So I'm going 3 up and 3 down from the center. So my foci here are going to be at, we're going to read the right here, negative 5, 5, and negative 5, negative 1. 3 up and 3 down from the center. Alright, well, let's do another problem that has to do with an ellipse here, just to make sure we get in a little bit of practice. What if I give you an equation, and instead of giving it to you in that form, I give it to you in standard form and ask you to find the center, the vertices, and the foci. Let's see what my equation is. X squared plus 2y squared is equal to 50. So what am I going to do with this? Well, alright, first of all, we need to get rid of this 50. Remember I said it was important that we were equal to 1. So I'm going to divide everything by 50. X squared over 50 plus 2y squared over 50 is equal to 50 over 50. That's going to give me my 1 on this side. And over here, I'm going to leave this for a moment as x squared over 50. We'll come back to that in a minute. What I'm going to do over here, I've got 2 over 50. I don't want that. I don't want anything up here with this y squared if I can help it. So I'm going to change this to, what will this fraction 2 over 50 reduce to? Well, it will reduce to 1 over 25. So I'm going to change this to y squared over 25. It's going to make this a little bit easier to work with. Well, is this A or B? Well, this number is bigger. It's therefore A, but it's A squared. So I want the square root of that. X squared over the square root of 50 squared. And the same thing with this one. I want to know what B is. I've got B squared. So this is the square root of 25 squared is equal to 1. Well, okay, this one's easy because the square root of 25 is 5. So y squared over 5 squared. This one might want to simplify. You could leave it as a square root of 50 if it was just me. Make sure you recognize that this is 5 square root of 2 if you simplify it squared. So we know that A is 5 square root of 2 and B is 5. So what are my center, my foci, and my vertices? Well, center is pretty easy. Do I have an H and K? I'm not adding or subtracting anything to X and Y, so my center here happens to be 0. I don't have X minus 3 or X plus 4 to change that. What about the foci? Well, remember the foci, C squared is equal to A squared minus B squared, so 50 minus 25 over 25. But I don't want C squared, I want C. C is equal to square root of 25. It's equal to 5. So if that's equal to 5, where was my bigger number? Was it under the X or under the Y? It was under the X, which means that this is going to go left and right. So I'm going to go left and right from this 0, 0. So my foci are at 5, 0, 5 to the right, and negative 5, 0, 5 to the left. What about the vertices? Well, remember that we're going left and right, and we are going the distance that is underneath of your X. So my vertices going left and right are at 5 square root of 2, 0, and negative 5 square root of 2, 0. I need to graph that. If you needed to graph that, just go through and put the points on. So, in order to find this, I have divided this by 50 and simplified. I need a 1 on the right-hand side, and I need to take the square root of both of these to figure out what A and B are. So I have H and K for my center. This is A, this is B, so A squared minus B squared gives me C squared. Take the square root to get C. This is going to be my center, and I'm going to go to the right C, and then I'm going to go to the left C. Here I'm going to go left and right A. Now if I want that top point on my ellipse going up and down from the center, how far up and down am I going to go? I'm going to go up and down 5, the number that's underneath my y. So that's what we do with ellipses when we need the equation of an ellipse.